Okay, you see that it stopped recording. I don't know when it stopped. Okay, so here this is 11 minus 2 times 6, which is 12, and this is equal to minus 1. And you can see term number 6 is indeed minus 1. And then you can see that our formula is correct. You can even calculate, let's say, term number 1,000, term number 1,000,000. So instead of you working out all those terms until you get to 1,000,000, you can just apply the formula. So let's look at maybe term 100. This is 11 minus 2 times 100. This is 11 minus 200. This is equal to 189.
It's the other book, Mommy.
So that's what you have over there. Okay, so you don't need to write all the terms up until 100. You can just use the formula to work it out. And again, you can see I checked if my formula is indeed correct. And me checking the formula that it is correct didn't even take me 30 seconds to do. Okay, because you can always check on your calculator. So let's look at another example. So we have to work out the common difference, the 10th term, and then a formula for the nth term of the arithmetic progression. So let's say I have 2, 5, 8, and 11, and it continues in this form. So remember, in arithmetic progression, the general formula of un, this is a plus n minus 1 times d. So I just need to figure out what is a and then what is d, and substitute and then simplify my equation as far as possible. So when I do that, a is just the first term that appears in the progression. So I'll have un, this is 2 plus n minus 1. Now the common difference, I know that from 2, in order to get 5, I must add d. So I know that 2 plus d is equal to 5, and this means that d is equal to 3. So if I add 3 here, I get 5. You can see that if I add 3 again, I get 8. If I add 3 again, I get 11. So my common difference must be the same throughout. I cannot have 3 over here and then 6 and then 9 over there. Then it's not an arithmetic progression. With an arithmetic progression, you have a common difference. That means any two consecutive terms, that means they follow each other, the difference is the same. So I know here now that my d is 3. Okay, then I will multiply my brackets out and simplify as far as possible. So I have un, this is equal to 2 plus 3n minus 3. This is just 3n minus 1. So again, very quickly, you check your formula, see if it's correct. So here, I'll check for u1, does it work? This means I have 3 times 1 minus 1. This is 2, so it's correct. Let me check for the third one. This is 3 times 3 minus 1. This is equal to 8. That is correct. So I can see my formula is correct. Then I am asked to work out the common difference. That was the first question. Said 1, find the common difference. So I say that d is equal to 3. And then the second question said find the 10th term. So I need to work out u10 over there. So I see here u10, this is equal to, I go back to my formula, 3 times 10 minus 1. This is 3 times 10 minus 1. This is equal to 29. And then the general formula, this is the one that we worked out already, which is un. This is equal to 2n. This is 3n minus 1. And that's what we have. Okay, so that's basically how you solve a question involving an arithmetic progression. Very important that the common difference is the same between any two consecutive terms, and then from there the value of a is just the first term, and then you can work out the formula for the arithmetic progression. So if we look at another example, number 2, we have 4, we have 6.5, and then we have 9. Okay, so 3 terms is enough to check whether it is an arithmetic progression, because you just check the difference there and also there, and if it's the same, then it is an arithmetic progression. So we know that if I say 4 plus d, I will get 6.5. So this means that d is equal to 6.5 minus 4. And this is equal to 6.5 minus 4. This is 2.5 or 2.5. And then I know what d is. A, I just look at my progression. So a is the first term, which is 4. So now I have everything that I need in order to write the equation. I know the value of d, I know the value of a, so I just substitute. So I say un, this is equal to a plus n minus 1 times d. So this is equal to 4 plus n minus 1, and then d is 2.5. So work this out. The 2.5 must multiply inside the brackets. So I have 4 plus 2.5 n minus 2.5. And then you subtract those 4 minus 2.5. This is 1.5, or 3 over 2. Plus 2.5, this is 5 over 2 times n. And again, we are asked to find the common difference. We did. We said the common difference is 2.5, and we're asked to find the 10th term. So we want u10. Now u10, this is equal to 3 over 2 plus 5 over 2 times 10. This is 1.5 plus 25. This is just 26.5. So you can try it, keep adding 1.5, keep adding 2.5 until you get to the 10th term. You will see that the 10th term is indeed 26.5. Then number 3, we have 7, 5.5, 4. Okay, and then it continues in this way. So with an arithmetic progression, again, the difference between any two consecutive terms should be the same. So if I work this out, I would say 5.5 minus 7. This is negative 1.5, or negative 3 over 2. And then if I say 4 minus 5.5, I would also get negative 1.5. So the common difference is the same. So this is in fact an arithmetic progression. So it's important to check that it is an arithmetic progression. And then what you do, we know that D is equal to negative 1.5. So my working here is just 7, not 7, it's 5. Let me just do it the way I've been doing it. I say 7 plus D is equal to 5.5. This means that D is equal to 1.5. Then, now that you have D, A, you will just read it from there. So we know that A is the first term, which is equal to 7. Then you substitute this into the general equation for an arithmetic progression. So you have UN, this is equal to A plus n minus 1 times the common difference, which is 3 over 2. So this is 7 plus 3 over 2 n minus 3 over 2. Okay, then you simplify 7 minus 3 over 2, that is 5 and a half. Times n. So that is what you would have. And then here also you can work out the 10th term. So if you want the 10th term, this is equal to 5.5 plus 3 over 2 times 10. Okay, then this is the same as 5.5 plus 15. And this is just 20.5. So that is how you would do that one. So it's very simple to work it out, nothing complicated. Then the ones that are a little bit more tricky, but you can still work out, is when you are given you're given terms. So I tell you, for example, the 10th term is this, the 15th term is this, the common difference is this. Can you give me a formula for the nth term? Okay, so this one is number 4. Now we are told to find the first term. This is what we are told to find, and also find the common difference. But what we do know about the sequence is that the third term, so U3, this is equal to 186, and we know that the 20th term, so this is U20, this is equal to 101. So we have to find U1D, and then further we're asked to find the first 3 terms. So that means we want U1, U2, and U3. So this is what we are looking for. So all we are told is, I'm thinking of a sequence. I know the third term is 186, and I know the 20th one is 101. Can you tell me what the first term is? Can you tell me what the common difference is? And can you tell me what the first 3 terms in the sequence are? So this one, just a little bit of algebra, nothing too complicated. So we know that this is an arithmetic progression. So we are told in the question that this is an arithmetic progression. Now with any arithmetic progression, the general formula is like this. We have UN, this is equal to A plus n minus 1 times D. That is the general formula. It doesn't matter what the arithmetic progression is, it can be written in that form. Now I know what U3 is. So I know that U3, so n here is equal to 3. So I will substitute 3 over there. I still don't know what A is, but I know here I have 3 minus 1, and I don't know what D is. But I also know from the question that U3, this is equal to 186. So I will ignore this part here and concentrate on this equation now. So what I have is this: A plus 2D is equal to 186. So this is the information I have using the third term. And then I do the same thing with the 20th term. So I know that U20, this is equal to A plus N here is 20. So I have 20 minus 1 times D, and this is equal to 101. So then again, I only concentrate on this part over there, and what I get is this: A plus 19D is equal to 101. So I have these two equations. Can somebody guess how I will solve them?
Simultaneously.
Exactly. So we did how to solve simultaneous equations. That is how you will solve them here. So you can solve them by elimination or substitution, because the question here doesn't restrict you. It's up to you to solve them. So I'll write them here. So I have A plus 2D. This is equal to 186. And then I have A plus 19D. This is equal to 101. So here I'm going to use elimination because the coefficients of A are the same and the signs are the same, so I need to subtract. So I say A minus A, this gives me 0. 2D minus 19D, this gives me negative 17D. And then I have 186 minus 101, this gives me 85. So I have negative 17D, this is equal to 85. So to get D, I just divide by negative 17, divide by negative 17. So this means that D is equal to 5. Okay, so the common difference is equal to 5. And now that I know what the common difference is, I will substitute it into the other equation and then solve for A. So I will say A plus 2 times D, which is times 5. This is equal to,
Miss,
yes,
Miss,
negative
is
5.
D not negative
Yes,
5?
yes, it is. So this is negative 5. So that's correct. It should be negative 5. And when I substitute it into the first equation, it should give me 186. So when I solve this, I will get A is equal to 196. So now I have my A and my D. Let me write this nicely. So there are my two solutions for A and D. So we were also told to first work out A, then work out the common difference, then we have to find the first three terms. So I need to work out U1, U2, and U3. Okay, so U1 I know is A, so that's 196. And then to get the next one, I add the common difference. So I add negative 5. So I have 191. And then to get the next one, I also add -5, but I know what the third term is because it's given in the question. It is 186. So these are the first three terms. Okay, so the questions will come in different ways, and you need to see how can I apply my knowledge of an arithmetic progression in order to solve these types of questions. So you just need to remember the formula for the arithmetic progression. Let's do the next one. So again, a little bit different. We are given this formula. We have 4, 7, 10, 13, and then I skip some terms, and then eventually I get to 100. Now my question is, how many terms must I write until I get to 100? Okay, so again you can check, is this arithmetic? 7 minus 4 you get 3, 10 minus 7 you get 3, 13 minus 10 you get 3. So this is indeed an arithmetic progression. So what I need to do is work out how many terms do I have. Now the way I can do it is find the value of n that gives me 100. So I know that the nth term is 100. So I know that un for some n, this is equal to 100. But I just need to work out what this n is. Because if I know what n is, then I know how many terms I have that I need to write in order to get to 100. So I need to work out the formula. So un, this is equal to a plus n minus 1 times d. This is equal to a, which is 4, plus n minus 1 times d. The common difference over here, we say 4 plus d is equal to 7. This means that d is equal to 3. So here I multiply by 3. Okay, then we simplify. The 3 should multiply out the brackets like that. So I have 4 plus 3n minus 3. This means I have 3n plus 1. That is my formula for un. Then from here, I know what the nth term is. It's 100 in this case because that's the last term that I have in the sequence. So I equate this to 100. So I have 3n plus 1 is equal to 100. And then I solve for n. So I have 3n is equal to 99. This means that n is equal to 33. So if n is equal to 33, it means in my sequence I have 33 terms, because when n is 1, I have only one term. When n is 2, I have 2 terms. When n is 3, I have 3 terms. And here when n is 33, it means I have 33 terms. So the sequence has 33 terms. Terms, and that's it. Okay, so we have just a few minutes. I want to do some of the questions in exercise 5.2.1. So as usual, I will do the odd numbered questions, then you can do the even numbered questions. This is exercise 5.2.1. Okay, in each of these we have to find the 100th term. So we're looking for U100. What is it equal to? So we're given, this is question number 1. So we're given the first sequence. This is 4, 1, minus 2, minus 5, and it continues and so on. So So the dots are important. They show that the sequence continues. It doesn't stop at -5. So again, you can always check, say 1 minus 4, this is -3, -2, -1, this is -3, -5, minus -2, this is -3. So this is in fact an arithmetic progression. Okay, then we can work out D. We know what A is. So I know that if I have the first term A and then I add D, that will give me the second term. So this means that D is equal to -3. And then my first term A, this is just 4, as I can see it in the sequence. Then I rewrite this UN. This is equal to A, which is 4, plus N minus 1 times D, which is -3. So this one will multiply inside and then I simplify as far as possible. So this is 4 minus 3n plus 3. And then what I get is 7 minus 3n. So again, always good, check your answer and see if it is correct. So you can start by substituting 1. If I substitute 1 over there, I will have 7 minus 3, which is 4, and that is the first term. Okay, so I know I'm on the right track. Then we're asked to find U100. This is just 7 minus 3 times 100. This is equal to -293. Okay, so that is the first question in A. Then for B, the same question, find the 100th term, and you're given another sequence. Now this sequence, you start with 2.5. You have 3.25. You have 4. And then you have 4.75. Then it continues. So the dot, dot, dot is there to show that I am continuing. Okay, then again, check if it is an arithmetic progression. The difference between those two terms, difference between those ones, and then the last two that are written over there, should be able to see that D is 3/4. But we can work it out. I know that 2.5 plus D is equal to 3.25. So this means that D is equals to 3/4. Okay, and then A, I just read it from the sequence. This is 2.5. Okay, so now that I have A and D, I write the formula for UN. This is 2.5 plus n minus 1, and then multiply this by D, which is 3/4. And then you multiply this out and then simplify. So you have UN, this is 2.5 plus 3/4n minus 3/4. So that you work it out on your calculator. You have UN 2.5 minus 3/4, that is 7/4, or 1 3/4. That's 7/4 plus 3/4 times n. And now the term we're interested in is the 100th term. So I look for U100. This is 7/4 plus 3/4 times 100. And again, just on your calculator. Here you should get 307 over 4. You can also write this as a decimal. This is 76.75. That is the 100th term. Okay, so I think I'll just stop here for now. I've been talking for 2 hours. That's too much. Okay, so go and do the rest of the questions, even the ones on inequalities involving absolute values, and even this exercise 5.2.1, go and try them. I see that the notes, or there's a folder on e-learning that says sequences and series, so the notes should be in there. Okay, if we have any questions, please ask them. Okay, I guess this means you are all fine. So if you are all fine, then I will see you guys on Monday, because we don't have class tomorrow. Okay, have a great weekend.
Likewise, ma'am.
Thank you.
Likewise,
Have a great
man.
weekend too.
Thank you.